Hello, my people. How are you? Hope you enjoyed our previous class on some practical solving some practical examples. In this clip, we will still do the same. We're going to continue with looking at some problems that has to do with taking the derivative of functions. As usual, in our first clips, one of my friends, Mr. Out of Press, helped us. In like manner, in this one, he will also help us as we continue. So this one is more of a continuation of the first class. Thank you as we introduce Mr. Autopress. Autopress, the class is for you, please.
Okay, thank you. My name remains Autopress Prince. Okay, we want to look at integration proper. Now look at this. And when you have this question, integrate x raised to the power of n. Now, how do we do that? This is what you're going to do. Integrate x raised by n can also be written as the integral of x raised to the power of n dx. Now, if we integrate this is what we are going to get. S raised by n plus 1. You add 1 to the power over n plus 1 plus c. This is the final answer. Provided n is not equal to minus 1. The condition for this to work is if n is not equal to minus 1. That's the answer. You have this, integrate x raised by 3 minus 2x plus 7 respect to the x. How do we integrate this? Very simple. This is equals to x raised by 3 plus 1, 3 plus 1 minus 2x raised by 1 plus 1 by 1 plus 1 plus 7x plus c. So this will give me x raised by 4 over 4 minus 2x squared over 2 plus 7x plus c. The final answer is x raised by 4 over 4. 2 we cancel out 2, I have x squared plus 7x plus c. That's the final answer. If you have this question, integral of 3x over x squared plus 2 dx. What do we do here? Very simple. This is what we are going to do. We are going to use integration by use substitution. So say let u equals to x squared plus 2. Let u equals x squared plus 2. Then we look for the u dx, du over dx. Du over dx will give me what? 2x. That will give me 2x. The next thing is I will now make dx the subject formula. My dx now will be equals to du over 2x. The x is equals to, carry dx this way, bring 2x down. So dx will be du over 2x. Now, I'll put in these two things into this expression back. So I have this, the integral of 3x over anywhere you see x squared plus 2, we replace it with u, beta u. Anywhere you see dx, we replace it with u over 2x. So I have du over 2x. X, we cancel out X. I have 3, I have 2. The 3 and 2, they are constant. Bring it outside the integral. So I have 3 over 2, the integral of 1 over u du. This will now result to, this is equal to 3 over 2. The integral of 1 over u is u. If you integrate 1 over u, you have what? U. Remember, if you differentiate the natural log of u, you have 1 over u. So if you integrate it, you have, if you integrate 1 over u, you have the u plus c. So my final answer will be 3 over 2. Playing, what's my u? U is x squared plus 2 plus c. This is my final answer. If you have this question, the integral of 5 raised by 3 x dx. Now for this, I want us to use shortcuts. What do we do? The integral of 5 raised by 3x dx. We are going to use a shortcut. What is the shortcut? If you have a raised to the power of kx, what will that be equals to? Let's find out. That will be equals to a raised by kx over k ln a plus c. This is standard that you must know. So this is what we are going to do. We have 5 raised by 3x. What do we do? This will be equals to 5 raised by 3x over, if you differentiate 3x, what would that give us? 3. Then your a now, comparing this with that, your a is what? 5. 3 in 5 plus c. These are final answer. If you are asked to integrate sine 7x sine 3x dx, what do you do? What do we do here? Let's find out. Well, this is what we are going to do. We are going to use this. Remember, recall from trig identities and trig. You do this. You say sine A sine B is equals to 1 over 2 cos Sorry, this place is minus, while this place is plus. Okay. So we are going to compare this with this. It means that sine 7x sine 3x now will be 1 over 2 cos A, where our A is 7x and our B is 3x. 7x minus 3x minus cos A is 7x, 7x plus 3x. This will give me 1 over 2 cos, what is 7x minus 3x? 4x. It's 4x minus cos, what is 7x plus 3x? 10x. Okay, so this is this is this. Since this is this, now we can now integrate. We can now integrate. I have written this in this form. It means that the integral of sine 7x sine 3x dx now will be equals to the integral of 1 over 2 cos 4x minus cos 10x dx. This is this. Let me wipe out that side. So the next thing is this. Bring out the 1 over 2 outside. I have 1 over 2. That's the 1 over 2 is a constant, so you bring it outside the integral. So the integral of, then I'll share the integral to both cos 4x and cos 10x. Integral of cos 4x, then share the x to it also, dx, minus 1 minus the integral of cos 10x dx. Okay. This will give me 1 over 2. If we integrate cos 4x, what do we get? First, you should know that if you integrate cos, you are going to get sine. The integral of cos is sine. But remember, when you are integrating stuff like this, you are going to divide it by that number. Differentiate the 4x you have 4, then you divide it by it. So we are going to, if we integrate cos 4x dx, this is what we are going to get. I have 1 over 2. Here I'm going to get sine 4x over 4. That's for this. Minus, the same thing is applicable here. If you integrate cos 10x dx, you have sine 10x over 10 plus c. Plus c. Now the next thing is I'll use the 1 over 2 to open up the brackets. Use the 1 over 2 to multiply everything inside the brackets. If you do that, your final answer becomes 1 times sine 4x is sine 4x. Sine 4x over 2 times 4 is 8. Minus 1 times sine 10x is sine 10x over 2 times 10 is 20 plus c. This is our final answer. You have this question, integral of 1 over x minus 3 x plus 4, yes. What do we do? Yeah, very simple. The first thing first is, this is we are asked to integrate this partial fraction. So we are going to do something to this partial fraction. Recall, in your first semester you learned how to decompose, to find the various components of a partial fraction. So this is what we are going to do. This 1 over x minus 3 x plus 4 is equals to a over x minus 3 plus b over x plus 4. Now we are going to look for the values of a and b. We are splitting into its various components, this fraction, into its various components. So we want to look for the value of a and b. Okay. How do we do that? Let's multiply everything by x minus 3 x plus 4. If you do that, this is what you are going to get. 1 is equals to a into x plus 4 plus b into x minus 3. Okay? After this, you will see by cover out rule. By cover out rule, let x equals to, by cover out rule, let x equals to 3. I want to get a first. Let x equals to 3. If x is 3, then we are going to get, when x is 3, and x is equals to 3, I have 1 is equals to a into bracket 3 plus 4 plus b into 3 minus 3. I have 1 now is equals to a into 7, a into 7. 1 is equals to 7a. Then divide both sides by 7. I have my a equals to 1 over 7. Okay? Next thing is, when x is equals to minus 4. When x equals minus 4. Let's see, when x equals minus 4, what will be the value of b? Okay, let me use this side. When x equals minus 4, when x equals to minus 4, I have 1 will be equals to 1 will be equals to a into minus 4 plus 4 plus b into minus 4 minus 3. 1 will be equals to, this will be 0, that will be 0. 1 is equals to a into 0 plus b into minus 7. 1 will be equals to a times 0 is 0. B times minus 7 will be minus 7b. Divide both sides by minus 7. I have b is equals to minus 1 over 7. So my partial fraction becomes, partial fraction becomes 1 over x minus 3 x plus 4 is equals to a, which is 1 over 7 becomes 1 over 7 over x minus 3 x minus 3. Here I have plus, but b is a negative sign. So the minus sign, we change the positive sign there too. So I have minus 1 over 7 over x plus 4. This is x minus 3 x plus 4. Okay. Since we have this now, I have this fraction as divided into its component parts. What do we do? What do we do now? We now integrate it. So since we have this, you can now say the integral of this dx now will be the integral of this part dx minus the integral of this part dx. And so if you do that, what are we going to get? Very simple. What we are going to get is this. I can factor out 1 over 7. 1 over 7 is something that is common to this and this. So I can bring it out. So I bring out 1 over 7 from this and this. This is what I'll get, 1 over 7 into brackets the integral of 1 over x minus 3 dx. Remember, I brought out 1 over 7. Then I'll put a bracket. And I write this part without the 1 over 7. Minus, you have brought out this 1 over 7, so this part will remain 1 over x plus 4. Yes. These brackets. Now, I have 1 over 7. Okay. That big bracket. If we should integrate 1 over x minus 3 dx. Now, this one, how do you integrate it? Very simple. What you look at is, you look at the denominator. The denominator here is x. If we should differentiate x, we are going to get the numerator 1. Since we are going to get the numerator 1, what do? We go ahead. We just apply a simple law in integration that says if you differentiate the denominator and you get the numerator, that is, if you differentiate this and you are getting this, you differentiate the denominator and you are getting the numerator, then your result is going to be the ln of the natural log of the denominator. Natural log of x minus 3. Remember, if you differentiate x minus 3, we are going to get 1. So this law says that if you should differentiate the denominator and you are getting the numerator, then your final answer is going to be the ln of the denominator. This is shortcut. Minus the same thing is applied here. Ln, if you differentiate x plus 4, you get 1. So my final answer here is going to be x plus 4. Okay. Then I can say plus c plus constant because I have integrated it. Okay. This will now give me, this is what I'll do. This will now give me 1 over 7. This, I'll apply the law of logarithms. Law of logarithm, these are laws. The x minus 3 minus the x plus 4. When there's a minus sign between two logs, what do? There's a minus sign, you divide. So you take the ln, then you say x minus 3. This minus sign becomes division sign. X plus 4 plus c. Next thing is Okay, this is x plus 4. This is our final answer. You can take the 1/7 to the front, or you can keep it there. That's the final answer. Thank you. Assuming you have this, x squared, x raised by 3 plus 4 raised by 4 dx. We are asked to integrate this. What do we do? Very simple. Okay. We are going to say, let x raised by 3 plus 4 be u. X raised by 3 plus 4 that is inside the bracket, let it be u. We are applying u substitution. Let u equals to x raised by 3 plus 4. And if that is u, we look for the u dx. The u over dx give us 3x squared. We make dx the subject formula. So I have my dx now. Bring dx this way. Take 3x squared downwards. Dx will be du over 3x. Dx now will be du over 3x squared. So the integral now of x squared into bracket. Remember, x raised by 3 plus 4 is u. So this will now become u raised to the power of 4 dx. Dx now is du over 3x squared. Du over 3x squared. X squared, we cancel out x squared. We are left with the integral of u raised by 4 du over 3. This is what is left. You bring out the 1 over 3 outside the integral. This is what I will get. I have 1 over 3, the integral of u raised by 4 du. Now this is equal to 1 over 3. You have integral of u raised by 4 du. Very simple. What do? Say this is equal to u raised by 4 plus 1 over 4 plus 1. So that will be u raised by 5 over 5 plus c. Remember there is multiplication sign. So I have u raised by 1 times u raised by 5 is u raised by 5. 3 times 5 is what? 15 plus c. So I have, what is u now? X raised by 3 plus 4. Substitute back. I have x raised by 3 plus 4 raised to the power of 5 over 15 plus c. That's my final answer. we have this question. What do we do? Very simple. What we are going to do is just integrate it. So let u equals to x squared plus 9 du over dx now will be 2x. The x will be du over 2x. So the integral of 0 to 4 x over u du over 2x. X will cancel out x. So I have this is equals to 0 or 1 over u du. This will now be equals to 0 or if you integrate 1 over u du, you have ln u. Sorry, I'm not supposed to write this again. I'm not supposed to put it that sign again. Okay? If you integrate 1 over u now, what do you have? You have the mu. Ln u. Okay? Here we have it as 0, 4. 0, 4. Okay. Anywhere you see u, okay. What are we going to write? S squared plus 9. So I have the x squared plus 9. Remember that is u. X squared plus 9. Here I have 0. Then here I have 4. Now what do we do here? This is a definite integral. Because it's a definite integral, that's how you do this. Anywhere you see x, you are going to substitute 4 first. So this is what I'll do. I'll say ln, anyway I see s, I'll write 4. 4 squared plus 9. I've written then minus then anyway I see x, now you write 0. 0 squared plus 9. So this will give me ln 4 squared is 16. 16 plus 9 is 25. Minus ln 0 squared is 0. Plus 9 is 9. This will give me ln. I have natural log of 25 minus natural log of 9. What do I do? There's a minus sign between the two logs. So I'll divide 25 over 9. Take one of the log, then divide. Now this is an answer, but we can still reduce it. Is equals to natural log. 25 over 9 has can still be expressed as 5 raised 5 over 3 raised to the power of 2, which is equals to 2 natural log. Take the 2 backwards. That's why I'm writing the 2 here. Natural log of 5 over 3. That's my final answer. if you ask to integrate exponential 3x dx, this is equals to exponential 3x. I just want to use shortcuts. Exponential 3x over 3 plus c. That's the final answer. Exponential 3x over 3 plus c. You can use the long process, but I just want you to know it. Just differentiate the 3x, you have 3, right? 3 beneath it, right? 3 beneath it. That is the answer, plus c. Okay, let's see. We have this. Integral of x exponential x dx. Now, here you cannot use integration by use substitution. We can apply integration by parts. But in applying integration by parts, you must observe this. LIAPE. In integration, you must observe this. This will guide us in integrating this. The L there stands for logarithmic function. The I there is inverse 3 functions, inverse 3 functions. The A there is, what's the A? What's the T? The T is 3 functions. What's the E? The E is exponential functions. What is the A? That is algebraic functions. Is it algebraic function? Okay, that is that. Now let's see. So when we compare this and this, our U must follow this. Our U must follow this. We have an algebraic function here and we have an exponential function here. We have an algebraic function in this light. We have an algebraic function. Then we have algebraic function comes before exponential function. So our U now, since an algebraic function comes, you have an algebraic function here and you have an exponential function, our U becomes the algebraic function. Our U is equals to x. Since our U is x, our dv now becomes e raised to the power of x. Now, what is going to be our du dx? Our du, if you differentiate our du now, differentiate u now, with respect to s, you are going to get 1. That will be 1 dx. Then, if you look for v now, will be the integral. For us to get v, we have to integrate exponential x. If you integrate exponential x, that is the integral of exponential x, we are going to get exponential x. So, we now apply integration by parts formula. Integration by part formula says the integral of u dv is equals to uv minus integral of v du. So therefore the integral of x exponential x dx, what's my u? X. What's my v? Exponential x. minus integral of what's my v exponential x, what's my du 1 dx. So this will now give me x exponential x minus the integral of exponential x dx. My final answer is going to be this x exponential x minus, if you integrate exponential x dx, what would that give us? That will give us exponential x plus c. This is my final results. If you have this, the integral of x squared in x dx. If you have to integrate this, what do we do? This also makes use of integration by parts. Remember I told you are going to consider this. Lines. We have a logarithm function. We have a logarithm function. Since we have a logarithm function, in life, logarithm function comes before algebraic function. In the question that I'm asked to integrate, I have algebraic function coming before logarithm function. But because this, in life, in this stuff, this was the order we are going to get our u. Our logarithm function comes before the algebraic function. Therefore, my u now is going to be ln x. U will now be ln x, while my dv will now be x squared. U is ln x. So if u is ln x, then du now is going to be, if you differentiate ln x, what would that give us? Differentiate in x, you have 1 over x dx. If you integrate dv now, you have v now. If you integrate s squared, what are you going to get? You have s raised to the power of 3 over 3. Remember, when you are integrating, you add to the power and divide it. Okay? So now we now apply the formula for integration by parts. Integration by parts is that u dv is equals to integral of u dv is equals to uv minus integral of v du. Okay, what's my u? Ln x minus my v s raised to power 3 over 3 minus integral of what's my v? S raised to power 3 over 3. What's my du? My du is what? 1 over x dx. Okay? This x here can cancel out one of it here. Cancel out one of it. So I have this, we multiply this. I have s raised to power 3 over 3 ln x minus, since the x here has cancelled out one of it, I have 1 over 3 the integral of x squared dx. X squared will now remain because one of it has cancelled out this. Okay, so I have this now. Let me move upwards. This will now result in s raised to power 3 over 3 ln x minus 1 over 3. If I integrate x squared, what will I get? That will give me, if you are integrating x squared, yes, we are going to add 1 to it, then divide it by the power. So that will give 1 over 3 times s raised to power 3 over 3. After I've integrated it, I will now add my constant plus c. So my final answer is s raised to power 3 over 3 ln x minus s raised to power 3 over 9 plus C. That's the final answer. If you ask to integrate sec squared x dx, this one you don't need to. There are standards, and the integration of sec squared x dx is what? Tan x plus c. That's the final answer. Okay, if you ask to integrate this, integrate 2x over x squared plus 5 dx. Remember, in the course of me integrating these things, I told you that before you have a fraction here. Before you rush to integrate, observe the fraction very well. Look at the denominator and compare it to the numerator. When I look at the denominator, I'm having x squared plus 5, and then the numerator is 2x. But if I should differentiate this denominator, if I differentiate x squared plus 5, I'll get 2x. Since the differentiation of the denominator is giving me the numerator, my final answer, there's no point solving. This is shortcut. The final answer is going to be ln of the denominator, ln x squared plus 5 plus c. Let's look at this. Integral of e raised by 5x dx. Integral of e raised by 5x dx. How do we integrate this? Very simple. Let's use shortcuts. This will give us, differentiate your 5x, what will that give us? 5. Differentiate your 5x, what would that give us? 5. So what we are going to get is e raised by 5x over what you have differentiated is 5, write it down, plus c. That's the final answer. Now this one we use, this one has standards. So just know the standards shortcuts. Remember I told you that if you have a raised by kx, integral of a raised by kx, this is the x. This is equals to a raised by kx over k the a plus c. You have integral of a raised by kx dx equals to a raised by kx over k dA plus c. So using this standard, comparing it with this, we have this integral of 15 raised by 20x dx now will be equals to what? What's 15 raised by 20x dx? That will be equals to 15 20x over differentiate 20x, what would that give us? 20 and 15 plus c. That's the final answer. What if you ask to look for the antiderivative of cos 3x? If you ask to look for the antiderivative of cos 3x, what will you do? Very simple. Antiderivative of cos 3x simply means that the word for antiderivative means the integration. Antiderivative is against anti, is something that is, this is derivative now, anti-derivative, the opposite of differentiation. And the opposite of differentiation is integration. So we are asked to integrate cos 3x dx. That's what you should know. This word should not confuse you. Now, if you are asked to integrate cos 3x, what are you going to do? First and foremost, shortcut, differentiate 3x. What would that give us? We should differentiate 3x, what would that give us? 3. So, then if you integrate cos, what would that give us? If you integrate cos, what would that give us? Sine. So I'll write that sine 3x over what you differentiated was 3. Put that 3 under the right plus c. That's the answer. If you have this, the integral of sine squared x cos x dx, what do we do? What do we do? You say let u is equal to sine x. U should be equal to sine x. And if you use sine x, then du over dx now will give us what? Cos x. And since du over dx is cos x, it implies that dx now will give me what? Du over cos x. So the integral of, anywhere you see sine x now, what we are going to now write is u squared cos x. Anywhere you see dx now, what you are going to now write is du over cos x. So cos x, you cancel out cos x. I have the integral of u squared du. This will now give me u, this will now give me u raised to the power of 3 over 3 plus c. What's my u? Sin x. Sin x raised by 3 over 3 plus c. That's my final answer. Now you have this. Integrate 3x squared dx. Then I have 2, I have minus 1. What do we do? Very simple. Very simple. So this is what you are going to do. You say 3x raised by 2 plus 1, 2 plus 1. Okay, we have integrated it. Then you now apply your minus 1, 2. This will give me what? 3x raised by 3 over 3 minus 1, 2. 3 will cancel out 3. I have x raised by 3 minus 1, 2. Anywhere I see x now, this is what you are going to do now. Anywhere I see x, write 2. So I have 2 raised by 3 minus. Anywhere I see x now, write minus 1. So minus 1 raised to the power of 3. What is 2 raised by 3? 2 times 2 times 2. That will give me what? 8. What is minus 1 raised by 3? Minus 1. So I have 8 minus minus 1. That will give me 8 plus 1. Minus and minus is plus, which is 9. That's the answer. Let's look at this. Integrate 2x minus 7 raised to the power of 3 dx. What do we do? Okay, you say let u equals 2x minus 7 du over dx now. Measure 2x, you have 2. Measure 7 is 0. Dx now will be du over 2. So the integral, this one now becomes the integral of u raised to the power of 3. Dx now is du over 2. Carry the 2 outside the integral. What I have left is 1 over 2, the integral of u raised by 3 du. This is 1 over 2. Now, if you integrate this, what do you have? U raised by 4 over 4 plus c. That will now give me u raised by 4. 1 times this is u raised by 4. 2 times 4 is 8 plus c, which is u. U is 2x minus 7. That is 2x minus 7 raised to the power of 4 over 8 plus c. So if you have this, the integral of exponential 5x plus 4 dx. If you should integrate this, what are you going to get? Very simple. Differentiate 5x plus 4. We are using shortcut. Differentiate 5x plus 4. If you differentiate 5x plus 4, what would that give us? 5. Okay, so my final answer is going to be exponential 5x plus 4 over your differential. What you have differentiated is 5 plus c. That's your answer. If you are asked to integrate square root of x dx, this is equal to the integral of x raised by 1 over 2, 1 over 2, 1 over 2 dx. Now what we do? This is equal to x raised by 1 over 2 plus 1 over 1 over 2 plus 1. That will give me x raised to the power of plus c. So this will now give me x raised by 1 over 2 plus 1. We look for the LCM. We look for the LCM. Put over 1 here. Here also 1 over 1. Look for the LCM. If you do that, this is what you are going to get. You have x raised by the LCM of that is 2. 2 divided 2 is 1. 1 times 1 is 1 plus 1 divided 2 is 2 times 1 is 2. The same thing happens here. I have 1 plus 2 over 2 plus c. Okay. Finally, my result now becomes x raised by 3 over 2 over 3 over 2 plus c. Now what happens here? This divided by 3 over 2. So I have x raised by 3 over 2 divided by 3 over 2 plus c. If you do this, I have x raised by 3 over 2. Division sign here changes to times. Then you take the reciprocal of 3 over 2. The reciprocal of 3 over 2 is 2 over 3. 2 over 3 plus c. You have 2 multiplied this. I have 2x raised by 3 over 2 over 3 plus c. That's my final answer. Assuming we are asked to integrate 1 over x squared, what do we do? We are asked to integrate 1 over x squared. We are asked to integrate 1 over x squared dx. This is equal to x raised by minus 2 dx. Now that will give me, that is, it means that you are asked to integrate that. So now this will now give me x raised by minus 2 plus 1 over minus 2 plus 1 plus c. That will give me x raised by minus 1 over minus 1 plus c. That will give minus x raised by minus 1 plus c, which is the same thing as minus 1 over x plus c. X raised by minus 1 is, x raised to the power of minus 1 is 1 over x. So I have minus 1 over x plus c. That's the final answer.
Minutes.
We have to integrate x squared plus 4dx. These are very simple things to the right. This will give me what? That will give me x raised by 2 plus 1 over 2 plus 1 plus 4x plus c. That is x raised by 3 over 3 plus 4x plus c. Final answer. You have to integrate the cube root of x dx. This is equals to the integral of x raised by 1 over 3 dx. Okay? Since we are asked to integrate that, what do we do? Very simple. X raised by 1 over 3 plus 1 over 1 over 3 plus 1 plus c. We take the LCM. This will give me x raised to the power of 2 over 1. The LCM is 3. 3 divided 3 is 1 times 1 is 1 plus 1 divided 3 is 3 times 1 is 3. Over the same thing, 1 plus 3 over 3 plus c. And so this gives me, x raised to the power of 4 over 3 over 4 over 3 plus c. This will now give me x raised by 4 over 3 divided by 4 over 3 plus c. Division sign, we change to multiplication sign, then you reverse. You take the reciprocal of 4 over 3. That will give me x raised by 4 over 3 times 3 over 4 plus c. This will give me 3x raised by 4 over 3 over 4 plus c. That's my final answer.